So guys, we are moving to the next, balancing a redox reaction. Balancing redox reaction. Okay, there are two proposed methods for balancing a redox reaction, that is oxidation number method and half reaction method. Okay, for an objective question, we simply need oxidation number method, because for solving a full reaction, oxidation number method will be more easy and less time consuming. Okay, but you know how to solve a redox reaction using half reaction method, but you simply know how to solve a redox reaction using how to solve a half reactions using half reaction method. So half reaction method is enough for solving half reaction, which means oxidized half reaction and reduced half reaction. Ready? So half reaction method is only enough for solving oxidized half and reduced half. No need of solving the whole reaction. So I said that the view is nothing but for solving a full reaction, we simply require oxidation number concept. Okay, so the logic, that is oxidation number method, and you will be an expert in this method, and you should a well expert in this method. Then only we can solve the questions regarding balanced reactions. Okay, and the steps are first, you check the all oxidation state. Check OS of all elements. Usually hydrogen and oxygen is not checked. Okay, no need of checking hydrogen and oxygen except peroxide or hydride. Okay, if hydrogen is in H minus state, then you have to consider it. Okay, or if oxygen is in -1 peroxide state, then you have to consider it. Otherwise, you simply check the oxidation state of other elements than hydrogen and oxygen. So check the OS of all elements. The next step, that is find or identify element with the change in OS. So you should identify which element have change in oxidation state. So once you identify the element with the change in oxidation state, then you clear that, or you realize that, oh, this element undergoes oxidation, this element undergoes reduction. Okay. So from this step, you obtain oxidized and reduced elements. Oxidized and reduced elements. So once you know the oxidized and reduced elements, you know how much electron it lost or how much electron it gained. So you simply balance the electron lost or gained by multiplying with a suitable number. Ready? Once you know which element undergoes oxidation and which element undergoes reduction, you simply balance it by multiplying with the suitable numbers. Okay, and that will be on the basis of the situation. Once the electron lost and electron gained are balanced, check the ionic charges on both sides. Then you should check the ionic charges, net ionic charges on the LHS and RHS of a reaction, left hand side and right hand side of a reaction. So if there is an excess in ionic charge, then if excess charge, then balance by adding, then you should balance the excess charge by adding H plus. H plus. If the reaction is in acidic medium, or you can use OH minus if the reaction is in basic medium. Ready? Okay. So if you add H plus and OH minus based on or to solve the or to make up the ionic charge, then the charge is also balanced. Okay, but there is an increment of hydrogen since you add H plus to the proper side and OH minus to the proper side. So you should balance that hydrogen using water. Okay, so that is the final step. Balance hydrogen using water molecule. So there is no need of balancing oxygen. Once you deal with this all step, or you done this all step, the oxygen will be balanced. Okay. We can implement that steps in your reaction. Let me have a skeleton reaction. MnO4 minus plus Fe2 plus. That is the oxidation of ferrous ion by permanganate. Oxidation of ferrous ion by permanganate in acidic medium. So you should know that permanganate, MnO4 minus. In acidic medium, the permanganate will be Mn2 plus. It is already said how to design the product, okay? And your ferrous ion will oxidize to ferric. And the reaction which is in acidic medium. So you have H plus with you. And this is the skeleton reaction. Ready? And let me write it once again. MnO4 minus plus Fe2 plus gives Mn2 plus plus Fe3 plus. Okay. So in a single step, which means in a single reaction, let me balance the whole. First of all, the first step, check the OS of all elements other than oxygen. No need of considering oxygen. So OS of manganese in permanganate, we know that plus 7. Or you can calculate the OS, you know, x into 1 plus like that, okay? So you know how to calculate. And this is a monatomic ion. So the oxidation state is mentioned here also. Already mentioned. It is mentioned here. This is also mentioned here. So the first step is over. OS of all elements, right? Yeah. So we get the OS of all elements. Now, what is the next step? Identify the element of the oxidation and change in OS. The elements of the change in OS is manganese plus 7 to plus 2, iron plus 2 to plus 3. So the elements of the change in OS is manganese and iron, which means you find the elements of the change in OS, which means oxidized and reduced. So which one undergoes oxidation? Which one undergoes oxidation? Iron undergoes oxidation. So this is oxidized and this is reduced. So identify the elements of the oxidized and reduced. Then balance electron lost and gained by multiplying with a suitable number. So then you should find how much electron lost and gained. Before that, we have a step. Identify element with a change in OS and make their numbers same. Make their numbers same. Listen. The elements of the change in OS is manganese and iron, right? So their number should be same before you balance the electron lost and gained. Their number, here 1 manganese, here also 1 manganese. So that's okay. Here 1 iron, here 1 iron. So that's also okay. If it is not okay, here 2 manganese and here 1 manganese, then you should balance it by 2. Then you go to the next step. Balance the electron lost and gained. So here the reduction, electron gained. Here the oxidation, electron lost. So how much electron gained? How much electron gained? Electron gained is, tell me, from manganese is changed its oxidation state from plus 7 to plus 2. So electron gained is 5 into number of manganese into number of manganese and into number of manganese. And number of manganese, you know, There is only one manganese. So the electron gained is 5 electron. And the change in electron lost or gained, you simply find the change in oxidation state between that elements. Yeah, plus 72 plus 2. What is the change in oxidation state? That is 5 unit. Into the number of such atoms. There is only one manganese. So change in oxidation state 5 into number of manganese, that is 1. So the total change in oxidation state or the total electron gained, that is 5. What about the total electron lost? What about the total electron lost? Total electron lost, the change in oxidation state, that is plus 2 to plus 3. Ion is changed from plus 2 to plus 3. Plus 2 to plus 3 means one electron, one is the change, right? One electron is lost. And number of such ion, there is only one. So the electron lost is 1. So here, 1 electron lost, but 5 electrons gained, right? 1 electron lost, but 5 electrons gained. So, what is the step? Balance the electron lost or gained by multiplying with the suitable number. So, the electron lost is 5, electron gained is 1. Then you should balance it by multiplying with a suitable number. We all know that the suitable number to balance these two numbers is, you should multiply the 1 with 5. If you multiply the 1 with 5, then what happens? Here will be 5, here also already 5, so both will be balanced. Agreed? So that 5 you should multiply with in front of your ion. Here also, here and here also. Is it okay? Because the change 1 is given by when 1 Fe2 plus turns to 1 Fe3 plus. So like that, there are 5 Fe2 plus should to produce in order to produce a change of 5 electron, a 5 Fe2 plus should turns to 5 Fe3 plus. That is the logic. Now the third step is okay. What it is? Electron gained and electron lost is balanced. Go for the next. What is the next step? You should check the ionic charge of both sides. Fine. How you can check the ionic charge? The ionic charge is the charge which is given in the question. The whole charge of the molecule which is already given in the skeleton question. The ionic charge of manganese is -1. So ionic charge of manganese is -1. And there is no stoichiometric coefficients. This is not the ionic charge. This is the charge which is given by me for my to check my change in OS. Okay. The whole ionic charge of permanganate is -1. And you should check, is there any stoichiometric coefficients here? No. So the charge of this species is -1. And the whole charge of Fe, that is +2, right? Yeah. And is there any stoichiometric coefficients? Yes, 5. 5 Fe2 plus is there. So each Fe have a charge of +2 and 5 like Fe means there will be a charge of +10, right? How it is? 5 into +2 and the total charge will be +9. Agreed? Yeah. Total charge will be +9. Is it okay? Then what about the charge here in the right side? The charge in the right side. Tell me, the charge in the right side. There is one manganese. So this can offer a +2 charge. There is 5 Fe3 plus and each Fe3 plus have +3 charge and 5 Fe3 plus means +15. Yeah. So here we have +17 charge, right? So in the left +9, in the right +17. So it is clear that the charge is not balanced. Is it balanced? No. There is excess of 8 positive charge in the right side. Here only 9 positive charge. Here is 17 positive charge. So excess of 8 positive charge in the right side. So the fourth step is over. What it is? Check the ionic charge of both sides. What about the fifth step? If excess charge, if there is any excess charge, yes, here is the excess charge because how much? Here we have 8 positive charge is excess. If excess charge is there, then balance by adding H plus or OH minus. That is based on medium. What medium is provided for us? The medium which is provided for us is acidic. So you can add H plus to the proper side. So the excess charge is balanced by adding H plus or OH minus. So there is an excess positive charge of 8 in the right side. So it is balanced by adding 8 positive charge to the left side. And that positive charge which is given in terms of H plus because the medium is acidic. Is it okay? We know that 8 positive charges exist in the right side. So you should make up, or you should you should give 8 positive charge to the right side. Okay. But the medium is acidic, so you can give it as in terms of H plus. So 8H plus is given to the, so that 8H plus will be to the left hand side. So the fifth step is also okay. Excess charge is balanced by adding H plus or H minus. Since our medium is acidic, we balance it by adding H plus. What about the last step? Balance hydrogen using water. Balance hydrogen using water. Fine. Is there any hydrogen? Here no. Here also no. 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 Yeah. Here we have hydrogen, because if you add some H plus or H minus to make up ionic charge, then there will be an addition of hydrogen also, right? Yeah. Because H plus and H minus have one hydrogen. Each H plus and H minus have one hydrogen. So 8H plus means there will be an addition, or there will be an increment or excess of 8H. Since it is left side 8H sorry, left side we have 8H plus. Then you have to balance the hydrogen with the right side, or to the right side. How you can balance the hydrogen? Using water. So 8H here, so you should add 8H2O here. Is it okay? No. 8H2O means 16 hydrogen. So you simply require 4H2O. 4H2O. So according to my view, the balancing is over. Then what about the case of oxygen? Oxygen will be balanced. If you are if you do the whole step in a well analyzed or well correct path, then oxygen will be balanced. For the final confirmation, you can simply check for the final confirmation whether the reaction is balanced or not. You can simply check the number of oxygen. Number of oxygen here 4. There is no oxygen here. So only in the left side there is 4 oxygen. What about the right side? No one here. Here is 4. So left side and right side I have 4 oxygen. Ready? So the reaction is balanced. So this is very easy, I think. Okay. So the steps are, you simply find the oxidation state of all elements. You can drop oxygen, hydrogen. Okay. And then you may have a conclusion which element undergoes oxidation, which element undergoes reduction. You simply make their numbers same first of all. Okay. Then you find how much electron lost or gained. If that number is not okay, then you can multiply it with a suitable one. Then you can find the ionic charge of both sides. If that is not also okay, you can balance it by adding H plus or H minus. Then there will be an addition of increment of or excess of hydrogen. Then you can balance it by water. It's very easy. It's very easy. Okay. We can do more and more examples. Then it will be okay with you or okay for you. Okay. Concentration of permanganate with the Fe2 plus in basic medium. Okay. The very same type of reaction, but it is in basic medium. So there is a small change. Your permanganate MnO4 minus, which is oxidized or which oxidized ferrous ion to the very same ferric. But this is in, there is a change compared to the previous question. That is, the reaction is in basic medium. Then what is the change? In basic medium, your MnO4 minus will turn to Mn4 plus. That is already discussed, right? Yeah. So this is the skeleton reaction. Okay. Let's check how it is balanced. So once again, I'm writing the reaction MnO4 minus plus Fe2 plus gives Mn4 plus Fe3 plus. Fine. What about the first step? Find the oxidation state of all one. So it is very easy. There is only you simply have to find oxidation state of manganese in permanganate. That you know, plus 7. Okay. The others are given in the question also. Plus 2, plus 4, plus 4, plus 3. It is given in the question already, right? Yeah. The next step, element with oxidation and reduction. Element with oxidation is plus 7 to plus 4. That is, reduction is manganese. Plus 2 to plus 3. Oxidation is iron. Fine. That's okay. Cool. Check their numbers are same. Yeah. Here one manganese, there one manganese. It is okay. Here one iron, there one iron. It's also okay. Then find the balance the electron lost or gained. So you have to find number of electron lost or gained. Number of electron lost or gained is found by checking change in oxidation state, +7 to +4. So the change in oxidation state 3 into number of such atoms, that is 3. So electron lost is 3. 3 lost. Sorry. 3 gained. What about the lost? Iron part undergoes oxidation, so it may lose electron. So what about the losing? The change in oxidation state, that is 1 into number of iron is 1. So loss of electron is 1. Gain of electron is 3. So that losing and gaining is not okay. So you should multiply with the proper number. So here we have 3. So 3. Is it okay? Yeah. So the third step is also over. So number of electron lost and number of electron gained is balanced by multiplying with a suitable number. The next step, you find the ionic charge. Here is -1. Here is 3 into +2. That is +6. So the excess charge is +5. What about here? Here we have +4. 3 into +3 is 9. So it will be +13. So there is an excess, here +5, here +13. Excess 8 positive charge though, right? Yeah. Here 8 positive charge is excess. And if excess charge, then balance it by H plus or H minus. We have basic medium. So we have negative charge with us. So here 8 positive charge is excess, right? Then you have negative charges. Then you supply 8 negative charges to the. If 8 negative charges supplied to the +13, what happens? It become +5. So both will be balanced. So here you should supply 8 OH minus, and that 8 OH minus will be enters to here. Finally, you should balance hydrogen. What about hydrogen? Here no hydrogen, here no hydrogen, but here we have 8 hydrogen. So you can balance it by adding 4 H2O. So finally you find the number of oxygen, 4, 8. There are also 8. So the reaction is balanced now. Is it okay for you? Yes. Moving to the next. Moving to the next question. And the next question that is we can do with a dichromate. We can do it with a dichromate and stannous ion. Let's check when dichromate treated with the stannous ion. Listen, the skeleton reaction is dichromate Cr2SN2- with the stannous ion, that is Sn2 plus. Okay, the reaction of dichromate, you know, it should be in acidic medium, and the dichromate itself turns to dichromate itself turns to Cr3 plus. Okay, and stannous will be oxidized to stannic. This is a skeleton reaction. Ready? Let me write it once again. Cr2O7 2- plus Sn2 plus gives Cr3 plus Sn4 plus. Okay, what about the first step? Oxidation state. Here +2, here +3, here +4. It is already given in the question. What about here? We know that each chromium in dichromate is +6. So element with oxidation reduction. Kitty, reduction is chromium, +6 to +3. Oxidation is tannin, tin. And make their numbers same. Here 1 tin, 1 Sn, here also 1 Sn. So that is okay. Here 2 chromium, but here only 1 chromium. So you should make it by inserting a 2 here. Did you understood? You should make the numbers. You should make the numbers of elements with the oxidation and reduction. Okay, then only you should find, or you have to find the electron lost or gained. So here we have 2 chromium, here we have 2 chromium. So you should only 1 chromium, but we have to insert 2 here. Ready? What about the next step? Electron lost or gained? How can we find the electron gained? here from plus 6 to plus 3. So 3 electron gained, but there is 2 chromium. So the change in oxidation state from plus 6 to plus 3 is 3. But we have 2 similar chromiums. So it will be 6. Is it okay? Yeah. What about here? Plus 2 to plus 4. It is fine. 2 is the change. And there is only 1 team. So 2. So here we gained 6 electron. There lost 2 electron. So you should multiply here with 3. So 3. So that step is also okay. Now ionic charge in the both side. The whole charge of Cr2O7 is 2 minus, and only one Cr2O7 is there. So minus 2 from here. Whole charge of Sn is plus 2, but there is 3 Sn. So it will be plus 6. What is a net charge? Plus 4. Listen here also. Whole charge of Cr3 plus is 3, and we have 2 Cr3 plus, plus 6. Whole charge of plus 4, and we have 2 or 3 tin. So that is plus 12. So here we have plus 18 charge. Plus 4 plus 18. So plus 14 charge is excess here. And what about the medium? Medium is acidic. So the excess charge is balanced by adding 14H plus to the left side. Then only 4 plus 14 equal to plus 18. So here we can add 14H plus, right? Yeah. So the charge is balanced. Go for the final balancing hydrogen. What about the hydrogen? Here we have 14 hydrogen. So it is balanced by adding 7H2O here. Okay. 7H2O to here. Ready? Okay. Fine. Okay. Let me do one more example. That is, so here 7 oxygen, here also 7 oxygen. It is also balanced, already balanced. Let me do one more example. One more. Okay. That is the case of permanganate with the MnO4 with the iodide in basic medium. So it turns to Mn4 plus and iodide turns to IO3 minus. Okay, let me show the question once again. MnO4 minus, and this is basic medium. MnO4 minus plus I minus become Mn4 plus plus IO3 minus. Ready? Fine. So first of all, the oxidation state plus 7 plus 4. Here minus 1. Here plus 5. Their numbers same. Whether the number is the change in oxidation state is for manganese and iodine. Here 1 manganese, here 1 manganese, here 1 iodine, here 1 iodine. So the numbers is already same. So electron gained. Here reduction, here oxidation. Electron gained, that is plus 7 to plus 3, plus 4. So 3 electron is the change in oxidation state and number of manganese is 3. So electron gained is 3. What about here? From minus 1 to plus 5. Minus 1 to plus 5. Minus 1 becomes 0, then plus 1, then plus 2, then plus 3, then plus 4, then plus 5. So 6 units is the change. And number of iodine is 1. So the electron lost is 6, but gained is 3. So this is not okay. You should multiply here with 2. Ready? And the 2 will be on manganese part like this. Then you find the charge. 2 into minus 1, minus 2. Here only minus 1. So minus 3 in the left side. Ready? What about here? 2 into plus 4, that is plus 8. And minus 1, minus 1. Only 1 IO3 minus, so minus 1. So here we have plus 7. So charge is not balanced, or charge is not okay. Then the medium is OH minus. Okay. Then you can add OH minus to here. Because if you add OH minus to here, then it becomes more and more and more and negative. If you add OH minus to here, suppose if you add 7 OH minus to here, it will be 0. Additionally 3 OH minus, it will be 3 minus 3. So minus 3. So if 10 OH minus are added to here, then the charge will be minus 3 here. So it will be balanced. So 10 OH minus to right side. If 10 OH minus is added to right side, then the charge is balanced. Go for hydrogen. There is no hydrogen, no hydrogen. And there is 10 hydrogen. So you should balance hydrogen by adding water. That is 5 H2O to the left side. 5 H2O to the left side. So it is balanced. As per the rules, it is balanced. So simply find the number of oxygen. Here we have 8 oxygen. We have 5. So 13 oxygen is in the left side. And we have 3 oxygen here, 10 oxygen here, 13 oxygen on the right side. So the reaction is balanced.